finishing chapter 7, lesson 1. So we talked about exponential growth and decay. So earlier we did a word problem with exponential growth. This is now a word problem going over exponential decay. So the formula for this is going to look a little bit different because it is a exponential decay scenario. So the formula that we are going to refer to is going to look like this. So y equals a. A is always your starting number, whether it be population. In this case, it's talking about the pressure of the atmosphere, and then it's decreasing from there. So this 14.7 is going to be our A value. Then you have 1 minus r. The reason we have 1 minus r is instead of talking about a growth where it's increasing, we have a decay where it's decreasing. So it says it decreases by about 20%. Again, if it's in percent form, you need to change it to decimal form. But if we're talking about a decay, that means I have a full amount and it's decreasing by that. So that's where the 1 is coming from. So it's not just 20%. It's really finding the other part of that. So if I have 1 and I subtract, or thinking in terms of percentages, if I have 100% and it's decreasing by 20%, the percent that I'm really looking at is 80%. This is going to end up changing to decimals since that's how you have to plug it into a problem, but that's where that comes from. Then it talks about, it says it decreases 20% for each mile of altitude up to about 50 miles. The 50 miles in this is not anything that's being used in your problem. So it then asks you to draw a graph to represent atmospheric pressure for altitude from 0 to 20 miles. 0 to 20 miles is going to be what gets plugged in to your T value. So that's kind of what you're using to look at and what you're plugging into. You do not necessarily have to plug in all 20 of those values into this scenario. Whenever I plugged in 1, or I plugged in 0, and then 1, and then 2, and then I plugged in like 8, 9, and 10 to kind of have some middle numbers, and then I plugged in 18, 19, and 20. So I kind of picked numbers from the beginning, the middle, and then the end. You are more than welcome to plug in all of them if you want to know specifics. Part B of this is going to ask you to plug in a specific number. There's generally going to be a question that follows up with like, part A is really making an equation and graphing it. Part B is going to be now that you've made this equation and you have a graph, find a specific number dealing with this. So plugging into your actual formula for part A, your A value is just 14.7. Then I have 1 minus. So again, if it's a percent, I'm changing to a decimal. So this would be 0.20, and then to the exponent of t. I would go ahead and simplify what is in your parentheses. So changing your 1 minus 0.2 to 0.8 to the t value. So this is really the equation that you're using and plugging into. So whenever you plug in and graph that, your graph is not labeled, so you do need to make sure that you label your graph. So your miles or altitude would be on your x-axis. Your y variable is the pressure, because that's what you're trying to find. So that would be your y value. Whenever I did this, instead of counting by ones, I counted, I labeled my graph by twos. You are more than welcome to do whatever makes the most sense to you. But if you label by twos, they all kind of fit on your graph versus going off. All right. So whenever you plug in 0 to t, kind of just as a starting point, you would just end up with 14.7, which would be in this general area. If you want to kind of, since you labeled your graph by 2, instead of plugging in 1, you could plug in 2, which is what I did. Whenever you plug in 2, you get 9 point, I forget what it is off the top of my head, but somewhere around that. So I would have a point right here. Then the next point that I plugged in was 8 and 10 to kind of have some middle numbers. So whenever you plug in 8, it's going to be somewhere around 3 point something. I don't remember what the number is off the top of my head. Then when you plug 10 in, you will get 1.58, so going down a little bit. And then if you were to plug in 18 and 20, you're going to get extremely close to 0, but not touch 0, is what these problems are going to look like. Similar to what we've been doing. So it's never going to cross 0 or touch 0. It's just going to get really, really close to 0 whenever you plug them in. So that's what your graph would look like. Again, please don't just sketch it. Have some actual points to plug in. That does not mean you have to plug in 0 to 20. Pick a couple from the beginning. So like 0 to 4, from the middle. So like 8, 10, 12, and then towards the end. So like 18, 20, to have a general idea of the actual shape of your graph, so you know how curved or not curved it's going to be. So that is your answer to part A. Part B, right here, then says to estimate the atmospheric pressure at an altitude of 10 miles. So for this, you are plugging in, and this is why it's important for you to know your equation. Because if you just look at the graph, it's going to be a big guess. So your t value is now specifically 10 of 10 miles. You are just plugging that into your calculator and answering. 10 is one of the numbers I did, whenever I plugged in to actually find the graph. So whenever you solve this, you would get y is equal to 1.58. And it would be atmospheric pressure. However you want to abbreviate that, you could just write AP or just pressure. It's fine either way. So again, similar to the other word problem that we did, where you do kind of have to make an equation, you're graphing it, and then there's a part B where you're actually going to plug in and answer.